Hi, everyone. Thanks for joining us today for Passive House Accelerator's very first Passive House walkthrough. Today is going to feature a Brooklyn Brownstone Passive House retrofit designed by Baxt Ingui. And our tour guides will be Michael Ingui and Will Connor of Baxt Ingui Architects, Kevin Brennan of Brennan and Brennan Insulation, John Mitchell and Ed May of Building Type, Kramer Silkworth of Bowcraft, and Andrew Fishman of SMR Craftworks. And they're listed here in the rough order of appearance today during the tour. So my name is Zach Semke, and I'm going to be coordinating the questions and answers. So as you have questions during this tour, please type them into chat, and I will be monitoring that chat and tracking your questions so that you can ask that question of the tour guides at the end of the session. And I also want to take a moment here to thank our sponsors for making Passive House Accelerators work possible. So a big thank you to our founding sponsors, Mitsubishi Electric, Zola Windows, RDH Building Science, and Baxt Ingui Architects. Also thank you to our stakeholder partner, the New York State Energy Research and Development Authority, NYSERDA, and to our patron sponsors, Morrison Hershfield and 475 High Performance Building Supply. We hope that this is the first of many walkthroughs. So if you have a project that you would like to share with the world, a project underway that you'd like to share with the world, please reach out to me at zach@passivehouseaccelerator.com and let me know. We can provide the logistics to make the walkthrough happen. If you have a project team, and can have somebody on site with a iPhone camera to document. So please do reach out to me, and we can chat about that. Our next walkthrough will be with Tessa Smith of the Artisans Group, likely in early September. So with that, I want to throw it to Mike. Please take it away, Mike.
Thanks, Zach. So I'm Michael Ingui from Baxt Ingui Architects. Put the mask off for 3 seconds so I can smile. We've been in business for a little over 40 years and partners with Ben Baxt. I've been with him for about 27 years, and we've got a great team at the office. Will Connor is a project manager for this project, and he's a principal at the firm. And we do a lot of townhouses, other projects as well throughout the tri-state area, doing a couple of houses out east and some apartments, but we do a lot of townhouses, and a lot of them are passive. And the reasons they're passive is it just fits this building type so well. It's hard not to do passive. We learned about it at first doing a project next to Sam McAfee and Ken Levinson on City Place. We were so enamored by it that we used Sam on some of our others. And since we've been just trying to develop a repeatable process to make it easier for others to do passive house as well. And we tried to share that in a couple of different things, including the Accelerator. And today we'll hopefully just show at least 1 or 2 ways that we're handling it for this. I think I'd like to start off with just a general question, which is always asked, which is, why do people do passive houses? And I think a lot of our clients, although they might be interested in energy efficiency, a lot of our clients are more interested in the benefits. So the benefits of a passive house include things like filtered fresh air 24/7. It's sealed from all bugs and dust and other things that might come in. It has even heat and even cooling. It actually needs very little heat. The heat in my house was turned on 7 nights this whole winter. So it's kind of a game changer. What happens when you don't need heat? Well, you don't need boilers and lots of other things. They have dry cellars. They minimize mechanicals, which is huge. You'll see that in this house, where you get to get rid of a lot of things that frees up the designer. And then finally, you save a tremendous amount of money in your cooling needs. If you're considering a lot of the things that you should be with a passive house, you really can downsize the cooling and then just add a little bit of heating into that system, and you get rid of a lot of mechanicals, and that helps to pay for some of the things you'd have to do for the house, which is nice. The next one. What do you get rid of with a passive house? There's no boiler. There's no pipes. There's no radiators. There's no thermostats all over the place. All the time in these old houses, we have to replace the flue. 6 stories of a flue is very expensive. And all this frees it up. You don't need in-floor heating all over the place. It frees up the designer, and it frees up a lot of costs. That's just a lot of money to save in doing these houses. So with that said, let's learn a little bit more about this house. We're going to start this tour from the top down, but while I make my way up there, Will give you a little bit of a tour of the house.
Thank you, Mike. Like Mike said, my name's Will. I'm working with Baxt for a number of years, done a few passive houses as a team that you have here. This house, just sort of to give everyone a little bit of context, this house is located in Brooklyn. It had always been a single family home. Actually, only one family had owned it for many, many years until they sold it to our clients who bought it a year or two ago and started a renovation. They're a family of 5. A couple of key notes. Where Mike was standing in the front yard is due south. So the house faces south. It's got an adjacent building next to it to its east, but then it's got an alleyway to the west, which is not always typical. And we have some interesting moments in the house that we'll get to, where we've got party walls that have windows where maybe in most townhouses you don't really get that opportunity, and bring a lot of light, and a lot of interesting things happen in the space that way. Another thing I want to note, I'll switch to the section here to kind of describe it a little bit better, but the house as built is what we call a basement +3. So it's a ground floor level at grade, or slightly below grade, and then it's 3 stories above that. This house was unique in that it also had an attic with really tall ceilings. So I'll get to the section here. Interesting about the house, so basement +3, so basement level here, and then 1, 2, 3 floors. This house also had an attic space that to the city was not habitable. And this house, according to the city, was also overbuilt. We didn't have any extra square footage that we could apply to this level up here. But it's really, you'll see when Mike gets up there, there's a lot of fantastic views, and it's a great space. We wanted to capitalize on that. One of the ways we did that was to actually take so-called square footage from the lower floors and apply it up at the top. So hopefully you can see this. Now, again, grade is at this level, first floor. We took the back portion of the first floor and lowered it down, which did a number of things for us. It took all of the square footage of this grade level and freed that up where we could apply it to the upper floor and create a habitable space. So we went from a house that, according to the city, was a basement +3 and created a basement +4 situation with this attic kind of office studio space for our client. The other thing that made, once we get there, you'll see, it made a really fantastic rear room that we're using as a kitchen that has a great connection to the rear yard. And Mike, if you're up there, I'm gonna stop sharing so you can jump back in.
I'm here. So as you can see, this is why you try to regain the square footage of an attic space. So as Will described, the roof used to come to here. The window system was the sill window. Again, in order to reduce some of the square footage that we were allowed to use, we pulled this back, which created a roof deck, which gives you the ability to walk out and see this. So you got Statue of Liberty, typically, if you have the space inside, and this house did. So it also provides some challenges. This was interior space. These were floor joists for the attic space. They had to be restructured. So now we've got a parapet, a roof with a room below. And then as we go through, we have our Zola door. I think Sam from Zola's on this in case people have questions about the Zola door. We've got our Zola door. We've got our head detail. And then we start to get inside and you can start to see that come down. So this was the existing attic height, existing floor that we're retaining. And this is the new, and you can see the level difference, or maybe you can't, but there's a level difference of about 4 inches, 6 inches, and that's because of the insulation that's here. And maybe John and Kevin, you guys can talk a little bit about the door install, and maybe some more of this really interesting detail here.
Yeah, so this is Kevin Brennan from Brennan Insulation Air Tightness. doors, large doors like that sometimes are a challenge in passive house, but you know, they chose with a operable door, which is great for a certified passive house. And down at the bottom, there's plenty of air sealing details. I think they use the Proclima system there. Down at the bottom, I see that fleece Solido tape and the Vanna tape there, making it airtight. It's always a challenge to get that door in thermally broken free and airtight. But through, I think John has quite a few therm images or thermal modeling he might be able to show that should be able to help to explain how that door was installed.
So just taking a look here at the architectural section, you can kind of see what's going on, what Mike was just describing. We've got the old floor, which is now a roof over that, providing that roof deck on the exterior. And then we have the transition into that, Zola window, door and window system. And you can see we're trying to maintain insulation continuity from that roof deck up into that window system and then up into the third floor, the fourth floor roof. Challenging stuff, but we have a really fantastic contracting team who can make all this work. And so I'm just going to go through some of the work that SMR Craftwork did to pull this stuff off. So as I mentioned, we do have a continuous insulation layer at that roof deck over the existing floor joists, which are also insulated. And the idea is to try to keep that insulation layer continuous as we turn up and come into the installation of the door. And SMR came up with a strategy to do that using a combination of a insulated plywood box, so that sort of gray bit you see in the detail, and then a structural insulation material, Armatherm is what we used in this case. So that's a load-bearing material that can carry the weight of those pretty substantial windows and doors, but also provide some insulation value. So we get really excellent thermal continuity from that roof right into the door system. And you can kind of see exactly how they pulled that off. This isn't outside yet because they haven't removed the roof and the wall for that area. But the right side of my screen is the exterior and the left side is the interior. And you can see that sort of pinkish material, that's the Armatherm insulation coming up and covering the sill. And then you can see that you have a plywood box that's been, that's structured and could be then filled with insulation. So we can support the window on that plywood box, but also have really good insulation throughout. And just to kind of look at that thermally, like originally we had proposed just sort of stacking up that Armatherm insulation. That's that bright green color underneath the door sill. And that works just fine, but that's sort of an expensive way to go about it. SMR and Andrew and Billy came up with a strategy to do this in a slightly better way. And it ended up performing almost just as well and being a little bit easier to execute. So kudos to them for some good work there. And at the jam, we have some steel columns, but we wanted to keep those as thin as we possibly could. So we built plywood boxes around those columns and then installed the windows tight to them. And so we get, again, really good thermal protection, really low psi values at those installation details, and really thin lines, which makes the architects and the homeowner happy. So those kind of odd conditions got solved really, really nicely on site.
So anyway, you can see the column here. You can see how small and slender that is, which is really, really helpful. And that continues along. Because again, you know, you did all this work to have that view. It'd be nice if it weren't really cut off and you had quite a nice opening. We're going to talk about a few things as we go downstairs. You can start to see we've kept as much of the existing fabric as we could. We're going to again talk about this a little bit more, but in this house, we did not rejoist it. We kept the existing joists. We kept the existing subfloor. We are actually restoring this subfloor, and we are patching in with subfloor that we've gotten from other locations, and in fact, other houses. So we're reusing things that we've demoed off of the other houses. When we demo houses, people love to save the joist, but they don't love to save the pine because it's so soft. So the fact that we're doing enough of townhouses where we know we can get the materials, it's always nice when it doesn't wind up in the dumpster. But the other thing that would be great if John could talk about now would be the skylight. This is a really beautiful skylight. It's a great install detail. It's a passive house company, and it's nicely installed. So maybe John, you can talk about that a little bit. Oh, it's Lamelux, by the way. I should mention the name.
So as I mentioned, or as Mike mentioned, we're trying to reuse the existing roof rafters and joists wherever we can. In this case, we have the existing 3x sort of typical brownstone roof rafters, but we want to get as much external insulation as we possibly can on projects like this. So we're gonna install external insulation over the roof deck and get, in this case, 4 inches of polyiso insulation before we get the cover board and the roof, which is going to go a long way to really protecting this assembly. Now, what you don't see in this this particular thermal image is that we actually have a condition that's more like this in a lot of places, because not all of those roof rafters were salvageable or in good shape, and we had to replace a bunch of rafters. And we replaced those rafters with steel because that's what we need to do in terms of the engineering. That's not what we'd like to have in terms of the thermal performance. If you look at the difference between that wood framed roof and that metal framed roof, you can see this was an R52 with the wood framing, but we're at like an R39 with the metal roof rafters. So we do take a bit of a hit. Fortunately, we do have that external insulation that helps give us a good durable assembly, but we are going to lose a little bit of R value when we do that. So whenever we can, we try to keep the existing wood joists, but it doesn't work all the time. Just to talk a little bit about the air sealing strategy at the roof too. So we'll go into sort of the general approach to the building envelope as we work downstairs, but we have an air barrier membrane up against the existing masonry wall. And then we have a transition into a plywood air barrier on the underside of the roof. And you can see here, we have some existing wood, we have new metal, and we have all of that being encapsulated by this air barrier, which is the plywood. The plywood gets taped, so that blue Vanna tape is on the plywood there and sealed up against the masonry wall, so we get good continuity there. The folks at SMR really thought about this a lot. And came up with a really great system. You can see those sort of vertical, longer vertical pieces of plywood in this image. Those are removable strips that are covered over with a mesh netting, so that when they go to blow the cellulose in, they have an access port and also a ventilation port, because the cellulose is blown in under pressure. And we need to sort of relieve the pressure in the cavity when that gets installed. So they came up with a system where they can pull this strip of plywood out, pack the cavity with cellulose, and then put that strip of plywood back in. So really, really clever way to take care of that installation detail. Now, back to what Michael was talking about is the installation of the skylight. And see here, we have, again, that continuous insulation on the roof is maintained all the way to the edge of the skylight. And we install the skylight essentially on top of the continuous insulation. And this was the original detail, but we figured out a way to make this just a little bit better, and that we added a little bit of over insulation of the upstand of that skylight. So the skylight has a pretty good psi value already. So the thermal losses are pretty good to begin with. But as we add this little cant strip around the perimeter of the skylight, we get an improved installation detail. We get improved waterproofing in that we have good drainage away from the skylight itself. And we get a really, really low psi value and really good interior surface temperatures, which is what we want. If we had low surface temperatures at the interior in the wintertime, we could have the risk of condensation. But here we have a really great thermal performance and really high surface temperatures.
So you're seeing on site right now the finished road, not painted, but finished and taped. So here's an image of the assembly before the sheetrock was hung. So where you get to see the Lamilux FE skylight being installed, the plywood horizontal roof barrier taped, and then taped up to the Intello that bridges the gap from the surface of our air barrier at the ceiling to the inside face of the skylight framing. And this is something I wanted to bring up because the roof has always been a toughie for us, because this image shows something of why. You've got to get lights to different places. In this case, we had to get sprinklers to some places. And in some projects, we've had to really jump through a lot of hoops to box those things out. and tape those things off and make sure that they're sealed. In this case, because of the ceiling heights we had, we were able to sneak in all those elements between the air barrier and the finished surface of the wall.
So just to go into a couple of different things as well as some questions I can see coming into the chat before we jump into mechanicals. So here you can see what will be a flush sprinkler head. And just to talk about why we had to go with steel, where we had to replace some of the wood joists versus just bringing it into wood. You know, it always comes down to inches in these houses, no matter what. And the wood joist that we would have replaced the existing joist with for code would have been about 3 inches deeper. And as we start to look at these doors, you'll notice that these 6/8 doors almost come to the place where the existing roof was. And because we wanted to keep the existing joists going out and we're pitching with insulation, we needed a step. And you need a little bit of drainage here just to make sure water's not going to be coming into your house. By the way, we also have 2 drains up here and a separate case. Something were to go wrong. You just need to have water not cascade into the house. But that'll give you a reason or a sense of why we had to keep that reduced joist depth in this area. And you can see a few things here, which is kind of interesting as we start to talk a little bit about mechanicals. Well, one, day lighting. You'll see that a little bit more downstairs. We've got our Lamelux skylight here. We also have a walkable skylight here covered in plywood because we don't have glass here yet, and I like to live. But we've also created, instead of bringing the stair up in this location, you'll see this, we brought a stair up in this location just to kind of, creates a nice, interesting way to get up. You can see that window that we've added in the front, and it allows the skylight to be right below this. So what you don't see here is you don't see radiators. I don't see ductwork traveling through and what would have been an incredibly tight ceiling. I don't see heated floors, which would have required me to rip all this up. I don't see any of that stuff here. All I see is the supply ducts there. There's a small grill, and I see a small return grill here. That's it. That's it for the top floor of a house. And for those who know townhouses, the top floor of the houses, they can be really, really challenging. You can see an ERV supply back there for the energy recovery ventilator. And that's where Passive House really starts to free the designer. And Kramer, you can go into a little bit more about kind of the magical components of that. But one last thing I'll share. So this is a Zender unit, and Kramer's going to talk a lot more about that. This yesterday had beautiful sheetrock. It was just screwed on. They didn't tape it and everything, but they unscrewed it just so we can see how clean their install was. It's an incredibly clean Zender install. This was sheetrocked smooth to the unit. I mean, you could almost leave it exposed. It was so nice, except we're doing this video, so they had to take it down. That's life. You can see the Mitsubishi unit that serves this floor. It's not even that big, and it's above the floor. It works well. It's a really clean install. You can see some really fun detailing by the contractors, which is always great, including some of the rules, just to make sure they get it all right. And with that, Kramer, I will give it to you.
Thanks, Mike. Well, I don't know. I think they should leave the sheetrock off of that, or maybe just use some clear plastic or something, because that's a pretty nice install there. Yeah. So as Mike was saying, thanks to the insulation and airtightness of this building, the mechanical systems, the HVAC systems, are really greatly scaled back. And the 2 main systems that it has that make it different from most other buildings are that it's heated and cooled with a what's generally known as a mini split heat pump system. Chances are you've seen these around almost anywhere you go these days. They're becoming more and more popular, particularly in light commercial and retrofit situations. But because of our very low heating loads, and the advances in heat pump technology over the last decade or so, we can heat the entire building with the same system that we're cooling it with. And compared to a regular building, this system is anywhere between 1/4 and 1/3 of the capacity of what we would otherwise be installing in this kind of house if it weren't Passive House. So yeah, we have minimal ductwork, we have no boiler, we have no radiators, we have none of that stuff that costs a lot to run all over the place and is generally architecturally intrusive. Of course, it's still important to consider all that early in design, and working with a team like Mike's. It's, you know, we start pretty early in locating where we want to put these different units. You know, they're much smaller than typical, but they do still have, you know, installation clearances and requirements. There's about a half dozen different variations that we can install, ducted and ductless. But by working with the architecture team and the contracting team, you know, we can locate these units in drop ceilings over bathrooms and closets, and just have a couple of grills, so they really disappear pretty quickly. The other system that this house has that Mike was just showing is the Zender ERV, Energy Recovery Ventilation. It's a very airtight house for energy efficiency and durability reasons, so we need to make sure we have fresh air for people inside. You know, we often hear that buildings need to breathe. Well, that's not at all true. Buildings need to stay dry, which is what the enclosure is doing. The people inside need to breathe. So that Zender ERV is running 24/7, pushing fresh outdoor air throughout the entire building. It's filtered, goes through the heat recovery, so even in the dead of winter, it comes out of the system at almost room temperature without any actual heating elements in there. And it's the other half of it is pulling air back from the bathrooms and kitchens and other types of spaces like that to provide continuous exhaust out of those rooms. So we have this constant turnover of fresh air throughout the building. So you really have excellent air quality in these buildings for a, you know, really minimal expenditure of energy. And I think that's about it on mechanicals, because like I said, all the insulation and air sealing really reduces the need for all those mechanicals. So they're important, but they're kind of the smallest piece of the puzzle once the enclosure has been done really well.
Yeah, I mean, the only thing I would add, Kramer, is from the design perspective, you've touched on it a little bit, but getting the building sealed the way Passive House does and getting the insulation, reducing the mechanicals to such a degree that we've got a mechanical room somewhere located potentially in the cellar, in this case up on the top floor because we had the room for it. It really freed us up. We don't have ducts that have to get to the exterior wall. So anybody that's familiar with a typical townhouse, we would have an HVAC unit, an air handler that would have to get ducted all the way to the exterior and make sure that we're washing those walls with either cool or warm air. Always a challenge design-wise to make a nice space, but without dropping ceilings and without creating soffits, and satisfy that. So architecturally, Passive House can change the game when it comes to that as well.
Yeah, good points, Will. And there's a couple of questions popping up now that I'll just take really quick. For the most part, we have about one air handler per floor for buildings like this, and they're in the 1 ton range each, 12,000 BTUs each. This whole house has one 5-ton system for the majority of it. And there's actually a separate 1-ton system that handles the attic room because that's got very different exposure from the rest of the house. So I wanted that to, you know, be able to run independently of the rest of the house.
So you can start to see I'm on the floor below, and you can start to see that skylight, or what will be a walkable skylight. We'll get to the plastic crown in a second. This is that staircase, and we're at a perfect place in this house where we can really start to talk a little bit about how do you air seal the house and what are the benefits. Of course, I always talk about the bugs and the dust because I think most of the people that I deal with don't even know that you can do that in Brooklyn. And have houses that are healthy where you're not even using your allergy meds. But how do you do it? And how do you do it in a way that's still safe and it's vapor open? And we've got a rare point in this house where we've got everything open, and you guys can share a little bit on your screen after I describe it a little bit. And you're looking at the side wall. And just before Kevin gets in, you're seeing us joining our structural member right here, the front wall to the party walls. Every time we work in these houses, we're always making sure that we've reattached our front walls in the right way. They actually putting this liquid applied membrane below the steel. They put this on, they put it above their steel to make sure they've got things going. Sequencing is key. But maybe Kevin, if you want to kind of describe this a bit more, or John, whoever wants to do it, and I'll point for you guys.
Yeah, I can talk more about it. Andrew and his team did a great job at air sealing that wall with the Viscon. The Viscon is a fairly new product. Our first iterations of air sealing party walls, we used other products, and we're very happy to use the Viscon now. It goes on at a low mill thickness and isn't as doesn't need as much love. I feel it needs slightly less labor. But the big variable in this is the substrate conditions. As you can see that on the picture on the screen, they had to repoint some of the bricks, and based on how clean, dry, and smooth those are is going to base on how much material you use. They used an airless paint sprayer to apply the material, which makes it really quick to install, but the coverage rate sometimes can vary based on substrates, and the devil's in the detail. At the front of the wall where you're attaching the Intello membrane to the actual air barrier system, the continuity there is extremely important in that it's clean, dry, and everything gets attached to it. I can share my screen if you guys want. I can show some other options that are available that we've done on other projects.
Yeah, and Kevin, while you bring that up, one of the points that I would make too is even if this wasn't a passive house, a lot of the pointing that you saw, we would have had to do anyway. As when we exposed that wall and found some structural issues. You know, they're old houses, they've had water damage over time. There's always some brick repair, some brick replacement, and some repointing that gets done. So when we're preparing that wall for an air seal, it's not that much more to get it to a point where you'll be able to apply that Viscon.
Yeah, so you know, when you guys are doing these renovations, it's hopefully for the next 100 years that brick is going to be exposed. You want to repair it up for the next 50 to 100 years. So the substrate is a challenge. You can see on this picture we have a fully parged system, and then we have the fireplace hearth that then gets parged and smoothed over. But we have sequenced air barrier going in before all the structural steel elements are going in and all the other issues. So as you go across, this is a first coat of the Stowe Gold, but you can see how many little pinholes of the substrate are there. That's going to need a few extra coats. We do it with the Stowe Fill that's up here, and we continue on and on until it looks as perfectly monolithic as you possibly can get. So it's a challenge. This slide is great in that it shows how we're pocketing the structural beams, joists that are in there. This is a recess inside of here, and then up here is where it gets filled in and the air barrier keeps going across. I apologize that the automatic slideshow is driving everyone crazy, but we have certain pre-existing additions when we try and keep the joists, and we have to sister joists and replace them that need to be overcome. This is a separate project, but this is the conditions of real life. You can fit, you know, almost your fingers in between where those joists are. Then they start being sealed, and then it starts to come together with a separate system of a fluid applied air barrier going on top. But that's almost 3 coats going on that. So as your team goes across, you're going to need to make the decision. This is how it gets sprayed on. If you can see the video, guy from my team, Mike Salufo, is spraying on the air barrier, and it goes on in 2 coats, but he's giving it a little attention to detail, making sure it gets on at the proper thickness, and then we'll measure the thickness with the thickness tester. So that's other options for air barrier systems and options.
Thanks, Kevin. Let me just show a couple of details from this project just to show the actual, some of the solutions these guys came up with. So those are the brackets that we're looking at that Mike was just showing us. So these are in process. So this, before the bracket was installed, they painted that Viscon fluid applied air barrier membrane on the brick after it's been patched, then installed the metal bracketing, then sealed around the brackets themselves. And you'll see in the final photo or in the live shot that these are then totally Visconed over again. So belts and suspenders, and then even more. This is a ledger detail. So similar approach in that the team first applied that fluid applied air barrier membrane to the wall, then attached the ledger, and then sealed around the ledger itself. So a little bit of sequencing goes a long way into ensuring that this project is going to be airtight and that everything gets taken care of as we go along. We don't have to go back and try to patch things up after the fact. Where we can, we try to use ledgers like this because it just helps us so much in airtightness. If we can avoid the pocketing, it's a tremendous help. And then just some more photos of that detail.
John, I would jump in. A team member that's not on the call but should get a lot of credit is the structural engineers that we work with. And to your point about the sequencing, and Kramer about getting the engineers involved early, having the structural engineer there in the design meetings early on in the process to work those kind of ledger details out, like you're mentioning, finding place for large ducts or large mechanical items to go from floor to floor, and make sure that we've kind of dealt with that in this almost in the schematic design phase, or at least design development, so that you're not going backwards, like you said, and you're not adding ledgers or having to go seal over things because you've had to do something in the field.
That's right. Yeah, absolutely. Let's show maybe a couple more things just to sort of give the overall building envelope strategy so we can kind of all understand what we're up to. We essentially on this project have like a 5-sided box. As Will mentioned, we have a neighbor to the right in this photo, to the east, but we don't have a neighbor to the west. And so we have the front and rear party walls as we normally do in a row house, but we also have the side wall, I'm sorry, the front and rear walls, but also this, the west party wall as well that we have to insulate, which is a little bit unusual for, you know, the typical Brooklyn row house. Our strategy here is on any of these exterior walls is we're going to do a 1-inch space and then a regular 3.5 or 2x4 wood framing. So held 1 inch off of the existing masonry wall after it's been parged, patched, and made airtight. And then an 1.5 inch service cavity in front of that. So that wall assembly gives us about an R19 or 20 effective. And that's kind of where we want to be for this type of building. So we have our wall system. Anywhere where we have an exposed wall, we're going to use that system. And then where we have our party wall to the neighbor, we don't have to insulate that wall as carefully because that neighbor is presumably keeping their house warm as well. And so we don't have heat transfer between our building and the other. So we will have a slimmer wall there. Typically we do end up insulating that wall for sound and also for the, you know, contingency that person may move away or they may, you know, go out of town for a few months and not heat their home. And we want to make sure we don't have excessive heat loss in that situation. And
All right, guys, so you can actually start to see a little bit of that detailing on the side wall here. Here's the exposed wall. I'm at a side wall right now. And you can start to see that Intello coming up and being detailed the way John was just showing it. So you can also start to see things that we're thinking about ahead of time, like shade pockets. And one of the questions that comes up very often is how do you put shades on passive house windows? We've done it 2 different ways, and it's not really part of our agenda today, but I'm going to talk about it anyway, where we've actually just done a shade pocket, and we've actually installed in the space you have here just thin mini blinds. So we've done both. The other thing you can start to see here, which is kind of fun, is you can see how they're starting to tooth in the boards. This floor is already pretty well sanded, enough where we can start to see what we've got and what boards are worth keeping. You could also start to see the Intello on the rear wall being installed. As I walk downstairs, you can really start to see some of the great stuff that the contractor here is doing. We've got plaster that needed a lot of repair work because we were keeping a lot of the plaster. And this was a lot of fun and was challenging. You can see here, we've got our existing wood stair. The other thing you can see is something that we like to do in the office, which is when we have the space, we pull back the floor a little bit. You know, this floor was pulled right here. So you get no daylight in the center of these houses. So just pulling this off and getting that sun to come through means that I bet you during the day, they might not need any light here at all. But you can start to see that. We've got some pictures that will show the underside of these stairs. And you can see this existing crown and how it's been recast in some places because we pulled this wall back, and how it matches perfectly with the crown that we didn't even touch. And Andrew, who's here with me, can talk a little bit more about this. But before I let Andrew talk, the other question that comes up a lot and that I've talked about a lot is, wow, how do you find a contractor who could do a passive house? And the one thing I want to mention, all the air sealing that we've seen on this house, from the Viscon to the Intello, to what's happening at the stair that we're going to talk about, all that was Andrew. And this is Andrew's first passive house. In fact, he's doing 2 at once right now. And what's fun about Kevin, if people don't know Kevin, is he teaches a passive house tradesperson class, and he teaches everything he knows to everybody, which is really fantastic. And what's nice about that is you've got contractors like Andrew who know how to do this really well. And they've got people who can carve that rail so I don't have to throw the stair out. Andrew knows how to get the stair. He knows how to make a few new spindles so I don't have to toss the stair. I don't have to toss plaster molding. I can keep my old school lath on, or we can keep our wood floors. This one's not prepped yet. But to have a contractor who's already a great carpenter, know how to learn how to do a passive house in a 5-day class, and all of a sudden they've got this down with a little bit of help from someone like Kevin, John and Ed. I think it's huge. So anyway, I'll let Andrew take it from here. Talk a little bit about how you did this.
Hi, everyone. It's Andrew Fishman with SMR Craftworks. The great challenge of this house was keeping the staircase and keeping a lot of the plaster moldings. As you can see under here, this is original, and it tied into what became new because this wall got redone. So we had to recast a lot of the flowers, floral points you see here, and we're able to put them up on where we had new walls over here. So these are new walls with new castings. The real challenges become when you have large scale plaster moldings like we have here in the entryway. So all these moldings are original, and we took them down and reinstalled them back in the places where they were. In fact, we reconfigured the opening. It's no longer what it used to be. Now it's used to have a bit of a header over here. We took the header off and added to it. All right, so here we are in the parlor. We retained all of these moldings. In fact, we reinstalled those, and these never moved from the space they were on. Yet we're able to create a full air barrier from this lower wall over the plaster moldings to the wall above. And that was a huge challenge. And we wound up basically taking the old plaster and lath down and installing plywood supports under every 3-foot section of these things. And then we were able to, I don't know, Will has some images of this, I believe, where we were able to bring our Intello membrane up and tape to the bottom. Then up top, we went through the joists and we plywooded between the joists and basically dropped the Intello down from the top here, over and down. The beauty about the crown itself is that plaster is airtight. So we didn't have to worry about the surface of the crown. We just had to worry about how to attach our air barrier to the top and the bottom. So up until this opening, this was all pretty much left in place. We re-added this section here, as well as this section here. Will, I don't know if you got some detail on that?
Yep, I do, yep. Let me share my screen. Skip to a couple of different photos. Here's kind of starting from the beginning. This is where Andrew was just standing, obviously where the room had been completely demoed. You're seeing the existing joists of the second floor. This is the west party wall with the chimney breast, and we're standing kind of at the bearing line wall, which would have been sort of the middle of the house, roughly. And in fact, actually, in the layout, the way when the owners purchased them, it wasn't the original layout, but there was a wall here that was actually covering that bracket, if you can see that. But this gives you a good idea of how we did the air barrier. I say we, like I did all the work, but how Andrew completed the air barrier, where we supported the plaster crown with 2x4s temporarily, and then created a plywood shelf that became integrated into the air barrier itself. I think this one's a good one that shows a number of different things happening all at the same time. But what you see is the Viscon being applied to the wall as the first kind of air barrier. The wood studs, starting to do some insulating, and the plaster crown integrated with that. Another image from the front wall, and what you're starting to see here too is some taping, and we'll get to that in a second. This is the image that I think we really wanted to get to that really described it. So you've got the Viscon that's on the surface of the party wall behind this. You've got the Intello that's coming up here, and we tape just to the underside here. And then we really are utilizing the plaster crown as the air barrier. And on the top side, in between each joist, is a horizontal piece of plywood. And that crown is taped from there to the plywood that then takes this air barrier back. It's a pretty tedious process, but it's something that we felt really strongly about. The owners, our clients who have been outstanding, who kind of came to us and said, we want a passive house, but we also want to keep all of this historic detail. We don't want to get rid of this stuff, and neither did we, because it's beautiful. So we had to kind of figure out ways to make some of this work from the top side. So this is standing on the second floor now, looking down at that piece of plywood that we were showing from the underside before. So the plaster crown, the edge of it at the ceiling is out here. And this came back and then got into the same plane as the west party wall. This is another good image in general too, to just show how the joist work that had to happen. So what you're seeing is the existing joists that remained in place. Due to structural reasons, we needed to sister those joists, needed to make them stronger. So we sistered those joists, and then that entire assembly was wrapped and sealed and caulked back into the air barrier.
So there's Will in the bulkhead of the elevator room, actually sketching a detail with the contractor doing the framing and showing him where those are. So you don't do the work, but you certainly are helping to execute the work. And then the next thing I'd like to point out is that it's kind of important a lot of times to take team photos of a successful blow-a-door test. So these guys just passed their blow-a-door test, and you can see all the smiley faces on there because they're celebrating great craftsmanship. And without Will's details and Kramer's work on the HVAC and mechanical, and the guys from AEA on that project, and the general contractor, those projects don't become successful without true buy-in and great leadership like Will.
One of the things that you can see here is just how great the crown looks and how good a job Andrew did, but everybody's right. This crown is heavy, and when we keep plaster crown, which we do all the time, even in non-passive houses, when it's in good shape, we like to keep it. What you don't see is what we do to these things, because you just can't just keep it. Because very often we're at the shelf like these houses, and you see cracks, and you see these things falling, and they do fall, especially during construction when you actually have a lot of vibration in the house that you wouldn't have otherwise. So what you can't see, and what that plywood blocking really helped with, is the fact that these have been reconnected with plaster ties all over. And what Andrew is dealing with is saving things like this and then reinstalling them in places like that. And so this was just done. And it's done really well. You can start to see that plaster weld. You can start to see the fact that they've still got to finish that. You can see that we kept the medallion for here. But sometimes getting the medallions off isn't easy. And so that's what that medallion looks like now. So you can see the number of pieces. You can see they started to put a little plaster weld on that. They're going to get that done, and then they're going to put it up. So yeah, you could buy a new one, but it's not the one that was there. And we had to do a new ceiling because the ceiling in this particular spot was falling. You actually saw cracks kind of radiating in, which is very typical in these houses. So it's just really nice detailing. So there's two things on this floor that I want to go through, but being we're talking about old detailing, and Will, I'm assuming, we're hoping you have some old photos. Keeping an old stair is kind of interesting because you have to air seal around the stair. And guys, someone's going to have to correct me with our numbers, but we had an initial blower door. We haven't done one after that. But the initial blower door for this house was like high 0.7 or 0.8. So we did very well in a house where we're keeping a lot of existing stuff. But if they have the picture, can share the screen at the bottom of the stair, you're seeing a couple of different materials that we've used. You've seen some Stowe Gold. You've seen some Stowe Rapid Seal. You've seen Viscon. So that's a good picture showing all of it. Just having your materials, it's amazing kind of what's around now that wasn't around, that makes this a lot easier and cheaper than when we were first starting it. So this gives you a good sense of what that underside of that stair looks like and kind of the detail work that had to happen where you can see it. You can actually see the existing old stringer. And it's hard to see, but you can see the old stringer and you can see the liquid applied membrane being applied to the bottom of the stair. So it takes a little bit of time, but again, we didn't have to throw out a stair, which was really important to us in this particular case. So I'm going to head over to windows now, if you guys don't mind, unless someone else had something else they want to go through. So these, again, these are Zola tilt turns. They look like double hungs on the outside, but they are in fact tilt turns. Right now, this is turned in. Most people wouldn't really use it this way. They tilt it in, so it tilts in this way. And what's nice about that is it's good for security, and they perform well. You can start to see some of the detailing of this window. It's really nice, really nicely gasketed. My bedroom is in the front of my house, and I do not hear the garbage truck outside. It's amazing what these do. So although they're good for performance in terms of passive house, they're also great acoustically. So maybe, John, you want to talk a little bit about what you can see here after this. But what you're looking at, which John will show you, is you can see your sheetrock layer, and then what you've got the air seal tape. You've got the plywood box where they installed the window, and then you can see the window taped in. So John will talk a little bit more about that.
So we're looking at this window install detail right now. And you can see we have the simulated double hung window, and we need to keep it sort of in the same proportions as it was before. So it's pushed quite far out into the opening. So we're really up into that first layer of brick, that first wipe of brick. That's where our window is going to start. And that could be a real challenge in these masonry retrofits, to get a good window install detail that's going to be thermally optimized, but still put the window in the place where we want it. So we would love for that window to be right in the center of the insulation layer, but we can't do that because it just doesn't work with the sort of aesthetic requirements of the project. So we have to keep the window where it is, and we have to then work around that sort of obstacle. And in this case, we had existing wood lintels. That helps us a little bit, and that wood is like, it's an okay insulator. And so we have a sort of continuous insulation layer through the window and through the head there, and then transitioning into our insulated wall assembly. So that works okay. Fortunately, at the sides, we have pockets from where the sash weights used to live. And so we can take advantage of that thick space there at the sides, this sort of 4-inch space at the side of the window, and fill that with insulation and get really good thermal continuity from our wall into our window. So our insulation line goes kind of like this, and then takes a little jog, and then goes through our window at the jamb. So that works pretty well. At the sill, we're going to do something similar. We're going to actually chop back or remove this first bit of brick here, so that we can have our window essentially sitting on insulation. We have a plywood that's been supported by blocking at the front, and then the insulation layer from underneath the window gets to be continuous with the window install. So that's that window that we're looking at on the left that Mike was just showing you. In this project, though, we've got 4 different types of windows, then a couple of types of doors as well. Each of those is going to have different dimensions, but Baxt Ingui, because they're good and careful architects, is going to have everything line up. And so we have to really pay a lot of attention to these window install details. And SMR Craftworks spent a lot of time getting these details right, so that everything was just so and everything lined up just right. So that window to the right there is a different style. It's a fixed window, it's a wood frame, and it's on that party wall exposed to the neighbor. And so those are going to all be fixed windows, but they want to match, the lines want to match the simulated double hung units that are nearby. So we get those to all align. And this, on the side there, we had an opportunity to actually make the brick openings. And if we can make the brick openings, then we're going to make them the way we want. And that means we're going to provide space at the head and at the jamb and at the sill for insulation. So we worked with a structural engineer and came up with a system where we used three angles at the head to hold up the brick. And the second two, the interior 2 angles, are set off of the window by 4 inches or more. And that gives us plenty of room from insulation at the head and really simplifies our work. Let me just take a look at that. And so when we do our thermal imaging, this is sort of what it looks like. We get a pretty good install at the simulated double hung head where we have that existing wood sill. It's not amazing, it's okay. At the jamb, it's much better. We get good insulation, right at the jamb where the weight pockets used to be. At the sill, that's just fine because we have plenty of room under the sill for insulation. So those work out fine. It's the head where things are really a little bit challenging. but we manage okay on those. Back to you, Mike.
Thanks. So one of the other questions that comes up quite a bit, which we're going to have Kramer talk about a little bit, is kitchen exhaust. And so we're in the kitchen here, and although there's a lot of electric here, heat pump, hot water heater, heat pump, HVAC, we do have a gas range, and it comes up a lot. And the question is, how do you do it? How do you do it effectively? And there's definitely ways. We've done it in a lot of passive houses, and we've really tested them pretty carefully, and they work well. So maybe Kramer, you could talk a little bit about this.
So typically, or traditionally in passive house, because of the air sealing and everything, we try to use an induction electric cooktop and a recirculating filter hood over it to avoid you know, an extra penetration of the air barrier, one that's difficult to air seal well, and the energy loss associated with that. But you know, not everyone wants induction, as awesome as I think it may be. Some people still prefer gas. So we definitely want to vent the gas out. It's strangely, it's not really explicitly required by code that you vent gas ranges, but for obvious reasons, it's pretty important to do so. And do vent gas ranges in a lot of passive houses. It's important to consider trying to minimize the flow rate. You know, we try not to use these 1200 CFM monsters that you see in the showrooms. I try to do 600 CFM at most. It's important to have that the hood has good capture over the burners. You know, not a downdraft or something like that is just not gonna be able to capture the steam and smoke and everything. And then it's important to make sure that exhaust air is balanced by what they call makeup air. So there's a separate system in the house that is connected to the range hood to come on at the same time. It opens a damper, and there's a fan that variable speed fan that matches the exhaust flow of the hood with this makeup air replacing what's being pulled out. And there's different ways to do that. The simplest for the homeowners are these fully automatic systems that are connected to the range hood switch. They come on automatically. They'll heat the air if it's coming in too cold. So there are energy penalties, but these things are not used a ton. So that energy use, I think, is pretty minimal in the grand scheme of things. The ones we use, it's an all-in-one system by Electro Industries. I think they're out of Minnesota. And they make them in varying CFMs. It's a fan, damper, yep, there it is. Fan, damper, and electric heater. For 600 CFM, you needed, I think it's a 10 kilowatt heater. So it's not small, it's 240 volt, 40 some odd amps. But if you want to have a gas range, I think you have to vent it no matter what. And in any airtight building, passive house or not, you need to consider the makeup air situation.
Yeah, so projects that we're dealing with, they're going to be depressurized at 50 at around 400 CFM. So
yeah,
we have to open the windows and doors without makeup air. So this is the unit. Air sealing challenges are not that bad when you put them up against the wall there.
So this is the lower 3 floors of the house, everyone. The grade floor is here. The first floor, the parlor floor with the existing stair that goes up. And then by taking away the square footage, we're left with this kind of double height space that became the kitchen. So against that wall is the range, the gas range, and the hood. And like Kramer said, that's interlocked with the makeup air system, which this space, and I know we're about to go to the cellar and you can see some of these things. This space is the mechanical room that's actually outside the envelope. So the makeup air comes in from the exterior of the house here, and is dumped into the hallway of the cellar there, which is actually open to the floors above. It's an open stair that allows that air to come back through. And so this also gives you a good view of a space that I think Mike is standing in now, which is when you lower this floor from here to here and take away this floor, you get this nice double height space with the connection to the yard and so forth. But you also get a great cellar space that we also had the opportunity to introduce windows and a light well to that were tall enough that actually the top portion of the windows, it's a little bit hard to tell, but the rear yard is at this line. So the top portion of the windows are actually just above grade and brings a lot of natural light down into this room, which is going to be the husband is a musician, and it's going to be his studio.
They have it pretty heavily protected, so it looks pretty dark out there, but they had the protection off for a while, and it really does let out tremendous amount of light in here. So one of the things about, I mean, it's kind of fun to work on a project where you have to take away square footage, because you can create these kind of fun spaces, which is nice. But the other reason to really take a look at the cellar is just, it's a question that comes up all the time. What are the benefits of Passive House? And one of the benefits is we have a warm, comfortable, dry cellar where you can do things like studios and other fun things. So it's got a really nice concrete floor. You just can't see it because it's protected. You can't see that we have a Stego wrap, which is kind of a very thick mill plastic wrap that comes up pretty far, actually. Yeah, so there you go.
You can see that, but yeah.
Yep, I can. Yeah, so you can start to see the Stego wrap that runs all the way up, and it protects the whole cellar from any kind of moisture that would want to come in. It has a really great turn bar at the top. It's relatively easy to install. It's funny that I say that. I did nothing except for watch them. But it looks easy to install, and it tapes nicely to the Intello and to some of the other items that you'd really want to put in. And it creates a cellar that, I mean, it's really comfortable down here. So Ed and John, do you want to kind of go through kind of what this section looks like a little bit in plan, or what we've done below the slab a little bit?
Sure, yeah. So we have, under the slab, we have continuous insulation. And on top of that insulation, we have that Stego wrap. So that Stego wrap comes in, and then as you said, Mike, turns up the wall as well. Mm-hmm. And so we do that on projects where we have areas below grade. We try to bring that Stego up to grade if we can. Yeah, that's a great shot of the care that these guys took in installing both the Stego wrap and the insulation. Typically, we put the polyethylene or the air barrier on top of the insulation in order to keep the moisture from the concrete from sitting there in a pool. In this case, though, the contractor wanted to put the Stego wrap down first, and so did that, but then taped the seams of the insulation in order to keep the bleed water from the concrete from pooling there. So again, excellent, really careful work. And you can see how the sort of floppy edge bits are taped up against the wall, so that when the new slab does come in, it's going to be available to tape to for that next layer of Stego that comes up the walls. So from there, coming to the interior, they'll get mineral wool insulation. And then because our air barrier is on the outside of that assembly, or on the sort of colder side of the assembly, we're going to need a vapor control layer. So we get the Intello layer over the insulation layer.
So thanks, guys. I made my way outside just to kind of take a look at what this house looks like again from the outside. I realized that we went through it before everything started, but not afterwards. Some brownstone work here. So this house did look like this house, where you've got some cracks, a lot of the detail removed. At some point in the 40s or 50s, this was done. A lot of the detail removed. And what we've done is we've redone the brownstone, brought the details back. We've reinstalled just those two windows, but otherwise this is a relatively intact facade with the openings. You can start to see how they do it with the scratch coat. And it's important to deal with your facades. It's important, we haven't really talked about it, it's kind of for another talk, but it's important to kind of really think about how the water is going to be dealing with these thick masonry walls, and where it's going to be stopping or not stopping, and keeping the vapor open and so forth. And spend a lot of time thinking about that and considering it. It helps a lot when you're redoing the brownstone. But I do want to thank Andrew quite a bit. This is his job site, which is nice. It's been nice to have him on, and thank everybody else. And then I want to repeat what Zach said earlier. We've been excited about kind of sharing how we're doing this on this project, but there's a lot of other project types that you guys are all working on, and they're fantastic. And just like I learned from everybody going to the conferences, it'd be great to keep that learning going. If you have a different project type, a high-rise, a multi-family, a stick-built, however you want to look at it, it would be great to share it. We can help you guys put it together in a similar way that we have with this one, and we can keep these going. All right, Zach.
Absolutely, man. You guys, what an amazing job. This is I think you at this point you get a very rousing ovation for this presentation. We've gotten some great comments and also some great comments out on social media. So well done. I want to share. I'm going to quickly share this screen before we go into questions and answers to remind everybody of who you just heard from, and I'm happy to share contact information and connect people with these guides. So please email me at zach@passivehouseaccelerator.com if you want to connect with folks. Let's jump into the questions and answers. So the way this is going to work is I'm going to invite people in order of the questions as they were asked in the chat to unmute yourself and turn on your video and ask your questions. So the first one, and it could be that some people have had to go. We've retained almost the entire audience, but some folks have left. So I'll give you a couple of moments, and then we'll move on to the next question if you're not there. So the first question is from Teresa Little Avant, and this is you're looking for a contractor in New Jersey.
Yeah, so I have a 100-year-old Tudor. She turned 100 this year. So I'm looking to finish the attic and wondering if it's possible, would you suggest that I can pacify, that's my term, pacify the attic? It's completely blank and we're using it currently as storage. So I want to create a new space with a nice master bath as well as a bedroom and office up there.
Passive house Retrofit details, they can be done in stages. They can be done all at once. These projects that we work on are done all at once as they're a gut renovation, but you can very easily apply passive house principles to the top floor of that house. You just want to make smart future decisions and do it to the standards. It's great to work with somebody like Ed and John that can help you develop those details so that you can piece together floor by floor or facade by facade details there. So.
Okay, great. Thank you.
Great. Thank you, Teresa. Let's move on to Nelson. Nelson, you had a question about the roof terrace. Can you remove the pedestals and fill that space with additional insulation instead?
I can field that. We could, but if you recall from the details or when Mike was upstairs, it was really important to keep a step down, a turn up of the roof to the doors. I think Mike noted we have 2 roof drains and we even have the scupper off the back. We're really cognizant of water buildup and snow and ice buildup as well. So although I think we could build that insulation up, we'd end up with some waterproofing issues at the door.
Fantastic. Okay, Sean Santa Moore, you had a couple of questions, I think. You had a question about the contractor and a full sheet of Armatherm.
Yes, I know Ed talked about it privately, but for the contractor, did he have to order the full sheet and have to cut it on site, or did he get someone else to cut it for him?
They came in pretty small sheets. If I remember, they were like 2 feet by 4 feet. They weren't like a large, like a sheet of sheetrock.
Okay. Good to know.
And they were easily cut.
Okay. Using
our table, so we had no problems cutting it.
There's a couple of different Armatherm products, and the one that we use on this project is a high density foam. And the other, which you might be familiar with, is more of a structural thermal break with a much lower R value, but much denser. And you probably would have a hard time cutting that on site. But this is really just a really high density polyurethane foam.
So Graham, are you there? You had a couple questions.
I am.
You had one about insulating the plywood boxes, rules on sprinklers.
Yeah, how do you insulate? You had plywood boxes around the steel columns at the door opening. How do you insulate? Those were insulated inside, on the inside of that. How was that done? And then I was just curious what the rules are on fire sprinklers for single-family homes in New York.
Well, I mean, to start off with sprinklers, New York City, it really wants everybody to do sprinklers. So they make it difficult for you not to do sprinklers. So we, whenever you're changing the use, or you're changing a type of building, or you're doing an addition, or lots of ors, they really look to you to do it sprinkler. Now, although it's a lot of money to do a sprinkler, and a lot of times you have to bring new water surface in to do a sprinkler, The only positive is sprinklers keep you alive. And these old houses have a lot of old wood, a lot of really old joists. And if anybody has tried to, I tried to light them on fire. I remember we had a fire pit in our last house, and I'm like, oh, all these cool old joists that we're not using. Yeah, great firewood. They go up in seconds. They're not good firewood. It's horrible firewood. So sprinklers keep you alive. These old houses could use sprinklers. So it's expensive, but it's always nice to be alive and know you can get out. So, but it's in New York City, it's pretty tough not to do a sprinkler when you're doing a renovation of this size.
And John, you could probably speak to the thermal aspect of the steel, but if I recall, we have 2 inches of rigid on the exterior, or wrapping those steel columns, which I think did the trick for us. And that was a coordination issue, a coordination challenge of just making sure that Andrew and then the steel fabricator removed enough of the existing masonry beyond the masonry opening we were trying to create in order to allow that insulation in.
Yeah, exactly right. And Graham, I think your question might have been about the that 4th floor, the steel columns. And those were, the contractor made the boxes and sealed them on and left one side open, and then spray foamed and then shaved it back. So they made sure that they had perfect coverage inside that box before they sealed it up.
All right, excellent. So Jane Sanders, you're up next. You had a couple of questions.
Oh, hi. Yeah, Jane here. Yeah, I'm very interested in the window details and the use of the Armatherm. In the past, I've used compact foam for similar details. And I was wondering, at your skylight detail, there was a pink insulation that was different than the polyiso at the roof. Was that one of the rigid ones, or was that just?
Yeah, so the Armatherm is going to perform in a very similar way to the compact foam you were using. The compact foam is not available that I'm aware of. Maybe it is again, but for a while it was sort of like you couldn't find it.
Yeah, 475 used to have it, and I actually have located someone who does supply it. That I'm, it's not, and I'm hoping 475 can carry it again. But,
okay.
Yeah.
Yeah. In the interim, we've been using Armatherm, and but it is very expensive. I mean, the compact foam was expensive as well. But I mean, it's like $20 a board foot. So details like the ones that SMR came up with to kind of, maximize that material and that we, use as little as possible and get as much benefit as possible are really important.
Well, also, and it's related to that, at the jam detail of townhouses, you have more room in there to get insulation, but I'm working in other pre-war buildings now with more masonry. They don't have that offset in the masonry. So looking for something to use instead of wood blocking there. So finding a way to make a product like this less expensive and more available is something that would be really great.
Yeah, for sure.
Also something to use at the steel, how to handle the detail at steel lintels in other pre-war buildings.
Where there's no headroom there to fill in. Yeah. Yeah, I don't have any magic bullets, I'm afraid, for that one. And then your question about the pink foam underneath the skylight, that was just a high density XPS. And that was just a phasing thing. That's the material they had there at the time. So it could have been the polyiso just running through, but just they installed the skylight before the roofer was on site. So they used the XPS that they were able to get locally.
All right, fantastic. Okay, next up is Susan Rowley. Did new segments of that crown molding have to be made? Like,
was there like 3D printing or anything like that required, or did they really reassemble all the little bits and pieces?
We reassembled all the little bits and pieces.
Bless you! Wow, yes. Awesome.
Well, thanks. It was a lot of fun.
Thank you.
It takes a very special contractor, and picking one who can really take the time and the effort to do that is key. And again, it's been asked a lot. Well, how do you find a passive house contractor? Andrew has been doing that level of contracting forever. So once he can do that, he can do passive house. Yeah, you can learn that pretty quickly. So it's really picking the contractors who are already doing good work, and they pick up passive house instantly, which has been really helpful.
Susan also had a question about the timeline for the project. I missed if that was addressed, but what's the timeline?
So a project in New York City without COVID that doesn't include an addition is usually from start to finish, from the time you start swinging a hammer until finish, of this size, because it's a bigger house. 12 to 15 months. Can go to 18 if you're redoing some plaster and some other items we're doing here. It could be a little slower. We've done them faster when we're not keeping a lot of stuff. Houses with additions, that goes up to like 18 to 21 months. In terms of passive house, it's really the air sealing that adds time. So if I had to say, you know, Andrew, this would really be for you, I would say that it adds like a month. So when you think about money, you save a lot of money on your mechanicals. You save it on your boiler and all the other things that I described at the beginning. And then you spend it by air sealing, but you're not necessarily spending it on the air sealing material as much as the labor and the time to put it in. So it takes a little bit of time, and a lot of that can be sequenced in, but Andrew, maybe you could talk a bit more about that. I feel like that is the biggest difference in cost between passive and non-passive. Having said that, whenever I've asked a client what they've appreciated most about their passive house, it's the fact that it's air sealed from all bugs, dust, and everything else that's outside. So it's the thing that they like the most that has the largest impact.
Yeah, I think a month timeline is fair. I think it would be longer on a home like the one we're in, because this home had we had to keep a lot of the original parts to it. It also depends on who's doing the work. At SMR, my company, we did all the passive details. Another contractor might be bringing in a crew like Kevin Brennan's crew, who's fantastic. And by bringing in additional crew, you're going to move the project a lot quicker. So there, you know, there's many ways to skin the cat. It definitely 1 month to 2 months, I would say, is what it's going to add to your project. Materials are not cheap. They can add up, more so in a retrofit like this, where we kept a lot of the original details. But like Michael said, you're saving so much on the mechanical side, plus the yearly usage. It's well worth it.
I would add a little bit too, Susan. Things that could help make that 1 month or 2 months and not 3 months or 4 months is strongly encouraging. I hate to say require, but I think I should say require the contractor to take a passive house tradesman's course before. If they haven't done a passive house or haven't done the course, they should take that course or a similar before they jump into the project. They get a lot of fear, or not, and maybe that's worst case where they don't realize what the sequencing could be, and they learn the hard way what that sequencing could be, and you find delays when you're starting to swing hammers and not before. I don't think it's difficult. I'm not a contractor, so I can't really speak there, but I think once they get done and put their hands on it, I think they realize, like, okay, I can do this. This is just a matter of thinking about it slightly differently, and we found that that's been really, really helpful.
One thing I would add that helps that timeline is running the blow-a-door test as early as possible. Even if you have to mask off service windows, doors, something like that, getting that blow-a-door test done early helps to give confidence in the systems and the assembly, and it really pushes that fear away. So no matter who you're working with, just try and schedule 3 or 4 blow-a-doors to get them in earlier. And other things are testing windows and doors on the first install with, say, performance mock-ups on site is something we've moved to, and it's been very helpful.
Fantastic. Okay, let's move on to Matthew Jarsky. Matthew, you had a question.
There we go. I had a couple. I can remember one. At the skylight in the attic, the attic ceiling air barrier was plywood. And then where we turned up into the well for the skylight, it was Intello. I'm just wondering why the change.
I think it was really a spatial issue, you know, because they both do the same thing, but the Intello is, you know, very like paper thin almost. So we're able to bring the sheetrock up to a point on the frame of the skylight. If we had gone with 3/4 inch plywood as the air sealer there, it would have pushed the sheetrock further past and made the opening smaller.
One thing is to point out is that not all plywood is airtight. You need AC grade plywood, which is a special product. So not all plywood or OSB is airtight. And it's mostly space saving and not having deflection in that space. I agree with Andrew.
Enrique Bueno, who had a couple of questions regarding mini splits and air barrier. Question.
Yes, thank you. Could you elaborate a little bit more? You were talking about 2 different systems, one for the upper floor and one for the rest of the house. You were talking about 5-ton heat pumps. Could you elaborate a little bit more what the systems were and what type of indoor units did you use and where they were located?
So the bulk of the house is done by a 5-ton Mitsubishi City Multi system. I believe all the indoor units are the slim duct type, so they're 8 to 10 inches tall, and we hang them in drop ceiling spaces in closets and bathrooms, and then just have usually very simple ductwork that just comes off the unit and kind of splits to the front and back rooms. And a single central return. Most of those are in the 9 to 15,000 BTU per hour range. This house with that attic space on top, partially because of the exposure of it and the skylight and all the north-facing glass, I thought that would be better served by a dedicated single zone system, so it can run independently in heating or cooling mode as needed, depending on what that space needs, because it has fairly different exposure and solar loading compared to the rest of the floors below it.
That unit was what size?
That unit is an 18,000 BTU system, 1.5 tons. It doesn't actually need to be that big, but because of the heating of that system, that particular system, it drops at the low ambient temperature. So it's a little bit oversized for that space.
Thank you. And on the air sealing, did you ever consider air barrier product for air sealing?
The aerosolized air barrier, that type of system?
Correct.
It's a little challenging. Yes, we've looked at it. It's a little bit challenging, particularly in these truly connected row house buildings, because when you, for those of you who don't know, that aero barrier it's an aerosolized product. You pressurize the building, fill it with aerosolized sealant, and then that sealant goes and finds all the holes and fills them up, which works extremely well. The problem is we're connected to one of the problems is we're connected to our neighbors. And so that material is going to find its way out of the building and into the neighbor's building and begin to seal up the neighbor. So that could be a real issue. So we don't want to do that. There's some ways around that. If you know who your neighbors are, you can set up another fan in their building and actually take that wall out of the equation. But really it's not really applicable for most of our row house projects. Also, we're doing masonry repair, and we want to make sure that while we're doing that masonry repair, we put in an air barrier system that's going to last, as Kevin said, for 100 years. And the ones that we're using, either the Viscon that we used here or some of the other products, we know those are going to be good for a long period of time. So we put them in while we can.
Okay, thank you much.
Thank you, Enrique. Okay, so up next we have Alex Hayworth's question.
I'm curious about some of the basement detailing that was shown towards the end of the presentation, and perhaps I'm showing my ignorance about some of the building science, but I'm not familiar with the membrane that was used on the foundation wall, and I'm just wondering, is there a concern there long-term about that foundation, which has not been treated at the exterior? You haven't done any excavation. I mean, in my experience living in Baltimore, working on a lot of historic row homes, those foundations, even with excellent exterior bulk water management, they essentially dry to the interior. And perhaps I'm clearly not an expert in this area. I'm just wondering if that's something that you guys weighed or is not a concern.
Yeah, the approach there is to use that Stego wrap is what we used in this case. It's a really like a 15 mil polyethylene sheathing. So it's a true vapor barrier. And we try to bring that up to grade. So any bulk water that does find its way into the foundation will go, or through the foundation walls, will drop down and be managed in the drainage layer of the subslab. So that's the approach. And then the reason why we then have what seems like a redundant layer, that Intello layer on the interior, is that the vapor barrier, the Stego product, is up against the exterior portion of the wall. So it's on the cold side of the assembly. And so any moisture vapor that's in that room would condense potentially on that vapor barrier. So we need to protect that assembly from moisture vapor. And we do that with that smart vapor control layer of that Intello membrane in the front.
Peter Leonard, you had a question about tooth in the boards.
Yes, and I had another question.
Great.
About the joists. My question on the staircase was answered in the chat. The joists, are the ends of the joists out of the air barrier, outside the air barrier, and are they going into external walls? So is there, what caulking system was used for the ends of the joists, what materials? And is there any risk of water damage to the outside of the unventilated ends of the joists if they're in external walls? To do with the floorboards, I think I know the answer, but I just using some recycled wood, which is matching, and it's going onto the joists, so that they help this. Where you've cut out the bad joists, which are faulty, the old ones, and they had to be cut away, then presumably you just make up you put new pieces in onto the joists. So that's fairly straightforward, I guess.
Yeah, so with regard to the joist ends, unfortunately, we do have joist ends going into an exterior wall, which is, that's not ideal, but they're existing and there's not a lot we can do about it. There's been some research into, what's actually happening to those joist ends on historic retrofits, and it's not exactly what you would expect. They actually perform better than you would imagine they would, and nobody's entirely sure why. So there's not a ton we can do because those joists are existing already, and we do need to insulate that wall. We do seal around them, and we do make sure that the exterior of the wall is in perfect condition. So the entire exterior of the building was renovated and was brought up to speed. So we wouldn't have any bulk water issues. It would just be moisture vapor that would be the issue. And then the products that were used there, so the Viscon system was applied to the masonry walls. And then I believe that was Stowe Rapid Seal, which was used around the joist ends themselves. So it's a thick, long-lasting caulking type material.
Fantastic, thank you. So Lindsay Klein, you had a question about the air barrier and the beam pockets.
Okay, so Peter Leonard just was asking about that, which is great. But John, what about the other side of where we've got a shared party wall? Any concern there, or you're still just going around the joist and sealing it? It looked like about 1 foot in along the joist.
Same idea. We're actually much less concerned about those joist ends, and that air leakage is kind of non-critical because it's to a conditioned space, but we can't sort of subtract that out from our blower door testing, so we still need to air seal that wall. Also, it's good practice. It keeps bugs out. It keeps moisture and odors and things like that from your neighbors from getting into your building. But in terms of from a building science perspective, we're just not that concerned about those joist ends on the party wall.
Okay, and that's why you were okay with the stair as well, which is secured to the party wall.
Exactly. Keeping the stair only made Andrew and his crew's job harder everywhere else, because we knew there was going to be some leakage around the stair. It was just going to be that way. So they have to be perfect everywhere else so that we can have a little bit of leakage around that stair. But they did a fantastic job of sort of encapsulating that stair on 4 sides all around.
Yeah, one thing to bring up that's I'm reminded of all the time. We have always, way before we've been doing passive house, treated these houses when we do them to this degree as if we will be the last ones, hopefully, touching it for 100 years. And a lot of these sidewalls, whether they're exposed or they're a party wall, they need work. The joist ends need work. So we're repointing and really taking a close look at the brick anyway. We feel like we have a responsibility to. It's open now. It won't be open later. And if we do our jobs right, it won't be open for a really long time. Billy, the project manager here, also is reminding me that whenever we've reinstalled the joists into that wall, we're wrapping them before they get in. We used Grace as a product here just to wrap that joist and put it into that protected and prepared pocket. And then we've rapid sealed them with the Stowe product. And then in this case, use the liquid applied membrane on top of that.
Yeah.
There are 2 ways that these Zola products, and I'm sure the other companies have different limiters as well. But these windows have 2 options. One is you can get a key on the actual on the actual handle where the window will only tilt in and not turn, but they also sell a limiter so that when it turns in, unless you pop the top of the limiter, typical limiter, just like a casement window, limiter, it'll only open a certain amount. So you can get both types of limiters on these windows, and we've had them installed in multiple houses and they work well.
Great. So Irini Tarani is next.
I think I remember one question. I asked
Great.
if there were any fireplaces in this house and how did you handle that?
I can answer that pretty easily. We don't have any fireplaces in this house, so that solves that problem. But we have done wood burning and gas fireplaces in some of our passive house projects. I mean, in New York, in a townhouse, I'll say two things. One, the city doesn't want you to have them. They're not allowed you can't install a new wood burning fireplace anymore. But if your townhouse has, you can keep it. So, and clients, one of the reasons why they buy townhouses is to have that wood burning fireplace with the marble surround and all the beautiful details. And so the quick answer is typically what we're doing is, some of it's common sense. You have to seal the flue. We're typically doing a new flue, which we would have done anyway. You've got to introduce fresh air, which is something that we found people aren't doing as much as they should anyhow. But you've got to introduce fresh air into the firebox. We're typically rebuilding the firebox because it's very old to begin with and needed the work anyhow, but creating a good solid seal there. And then we've got a heat-resistant glass sealed door on the opening of the firebox, and that should stay closed all the time, but when the fireplace is on as well, and it's worked really well. We have a number of houses that have that, and it works. I'll also say that since passive houses are so well sealed and well insulated, we've got two types of clients. One type of client that's used their fireplace one time and realized that the house becomes degrees and they can't take it. And then we've got another type of client that really actually is only one person that I can think of who's become a friend of the firm, who loves his fireplace so much that he opens all his windows and turns and lights his fire.
One thing to point out too is that Mike and his team have done a great job of adding fireplaces to outdoor spaces on top of roof decks, and they've done an amazing job at that. So they've overcome those challenges on these other passive house projects. So they've done a great job.
And then we do a lot of it. I see it in the chat. We've done a lot of bioethanol. That's our first choice before we go to gas or wood inside the house. In fact, actually, if they're going to do gas, we do bioethanol. We can convince somebody to go to bioethanol over gas, but sometimes it's just too difficult to convince them to go over wood. We do a lot of outdoor fireplaces in place of indoor. We do what we can. But very often we're having to do a lot of the work to air seal them on the inside.
Awesome. Okay, Laura Blau, you had a question. It may have been answered, but I want to give you a chance to fire it off if you like.
So it was the makeup air and dampers at the kitchen. Does the makeup air have the damper on it, or do you actually also know of a product that is a good damper for indoor letting outdoor air in for when a client insists on, say, not having a heat pump dryer or having an exhausting fan?
This house and many others like it, I'm using a sort of all-in-one makeup unit that has the damper, fan, and electric heater in it, made by Electro Industries, and someone
I looked up that. I saw that.
Yeah, so that's the best all-in-one solution. If you want a simpler and cheaper one, almost any motorized damper system that has decent air seals on it can provide you with at least that motorized opening. You have to kind of rig up your own wiring with a transformer and a current sensor looped around the range fan circuit for it to know when to open. And I believe the same company actually also makes a box that has the same damper and fan, but no heater in it. I think that's relatively new. I haven't used that one yet, but I don't think it's substantially cheaper than the one that also has the heater in it.
Right, but if just you say that has a good seal, that's my question, because I used a makeup air unit, not this one, on a project, and we had a damper and the seal never sealed, and the client finally said, just take it out. We'll go back to a recirculating hood, but they do a lot of cooking, and I was disappointed that we weren't able to satisfy that. So it's the product of that, of a good seal, a damper that you know of with a good seal.
Yeah, I haven't done the damper only solution in a while, so I don't know off the top of my head. Might be someone like Braun or Aldes, ALDES. You kind of have to just buy one and take a good look at it to figure out if it has a good seal on it or not.
They both have motorized dampers.
Yeah. A number of companies make motorized dampers. If you get into the commercial scale stuff like Greenheck, they will have air sealing ratings on them, I believe. But I haven't used that approach in quite a while.
All right, thank you.
Sure.
Great, thanks, Laura. Up next is Keiko Spade.
Yes, maybe my question isn't really passive house type
That's
of
okay.
question. However, if I look at the sections and just when you were walking through the building, looks like all like 4 to 5 stories seems open to each other. Is that how you handling the sprinkler system or fire barriers in between? I thought like 3 stories is max.
Well, this is a single family residence, so we can have the opening, and 2014 code in New York City allows that, especially with sprinklered spaces. So it's a multifamily, like, you have issues, or if you're using an old code in New York City, you have some issues as well.
So this one is like all 5 stories open?
4 stories is, well, not technically, technically all 5 stories is open, and in New York City, and in the brand new 2014 code, fully sprinklered, you can do that.
Thanks, Keiko. Okay, so up next is Tom Phillips. Are you there?
Yeah, I was just curious about the masonry walls, because there's such a big problem in the UK when they retrofit buildings and have moisture and mold problems and so on. But I caught part of the presentation, so I gather you're doing all kinds of air sealing and moisture control, but also just the thermal issues or benefits with for cooling as our climate warms, with all the thermal mass there, and how it could be optimized maybe with night cooling or something. At least in the West Coast, we try to do that. But in any case, I think Ed provided some answers and discussion and a resource there from Scotland, I think, the Highlands or whatever. In any case, I'm just curious if they use future weather data to look at, whether thermal mass or other things would be needed to be, beefed up to handle the warming climate. So
yeah, for this one, unfortunately, because of the options that are available to us, we have to insulate this building from the interior, which means that we cut off the thermal mass from the interior space. I mean, with the exception of that one party wall, which is substantial, but it's we're losing the 3 other walls of the project. So we just didn't have that option. So we didn't model it. And I think you and Ed went through this in the chat a little bit. So there is some cooling benefit to thermal mass, not so much in terms of the heating. But where we can leverage that, we do, but we just couldn't in this case. And then to the durability of those masonry systems, that's really why we spent so much time and put so much care to the patching and repair of the masonry wall, and then the application of that a fluid applied air barrier. That product is essentially the same as having a weather resistant barrier on the inside of your building. Those are kind of similar formulations, the products that we would use on the outside of a building as to what we're doing on the inside of that masonry building. So we should be getting the same benefits in that if there is any liquid water finding its way into the building, it'll be stopped by that layer. But it does have vapor permeability so that it can dry in both directions.
All right, awesome. So next up is Paul.
Hi there. My question is really about the wall assembly there. I saw that you're using a 1-inch air gap in that assembly, and I presume part of that is to separate the insulation from the exterior wall. But if you change your insulation material, say to a polyiso, would you still need to maintain that air gap?
Yeah, I think it might look like an air gap, but it's actually a space for insulation to flow in around the studs. So we found that, and Kevin can maybe speak to this more specifically, but a 1-inch gap is a big enough gap for the dense packed cellulose to find its way back there. So what we're doing, we're actually looking for the opposite. We're looking for a continuous layer of insulation between our stud layer and the masonry wall.
Yeah, so furring the studs off the wall and having them, it creates that thermal bridge wall assembly with the studs, and we are able to get cellulose behind every one of the studs. So the cellulose will blow in dense pack at a high pressure, be 3.5 pounds per cubic foot, so it won't settle over time. It also helps you, on the reverse side, it helps you find where maybe some of your little air sealing mistakes might not be, because the dust blows out and it says, hey, I need to seal there. But it's a very good product, and it's much more reliable to get a 100% perfect install as opposed to doing bats. Bat insulation is not as easy to get to that level of precision that you need. So blown in tends to be done pneumatically, and it gets it done much better.
All right. Thank you, everyone, for attending and for these great questions, and for the tour guides for fantastic answers and a really engaging couple of hours. We've made it through all of the questions and answers, and so we're going to close up here, and I just want to throw it to Mike for a couple final statements.
Thanks, guys. Thanks, everybody, for attending today, and for Andrew for letting us do it, and for Kramer, Kevin, John, Ed. It's been great, and for you, Zach. Also, thanks to everybody in the office. There's a lot of people who put together these passive details over the last number of years and created this repeatable approach that we're doing in this house, as well as a few others right now. It was great that this house was in this kind of a place where we could do this today, and I'm really looking forward to the next one from another architect. And feel free to contact Zach so we can start to put these on the Accelerator. And on that note, I look forward to seeing everybody at tomorrow night's happy hour. Thanks, Zach.
Thanks, everybody. Have a great day. Take care.